So Oracle database consists of two different parts. One is instance, other one is database. And instance is a combination of memory and a set of background process, and database contains a set of files. So instance in the instance we have SGA and PGA. So SGA is shared area and PGA is private area. And if the database is a dedicated architecture, then we use user global area, which is UGA. And if it is if it is shared server, then we use UGA, which is user global area. And if it is dedicated architecture, we use PGA. There will not be any UGA. And almost 90 to 95% of the systems use PGA, so which is private global area. And SGA contains multiple components, which are shared pool, buffer cache, log buffer, and some optional pools like large pool, Java pool, streams pool, flashback buffer. And database contains files like control file, data file, online read log file, archive log file, and flashback log files, which is also optional, and P file. So mandatory files are control file, data file, online read log file, and P file, also password file. And archive log files, if enabled, then archive log files will be generated. So if archive log is not enabled, there will not be any archive logs. But in production systems, archive logs are necessary. So if it is the test machines, obviously most of the systems may not be having archive log generation, but still that depends on the organization. Some organizations may enable archive log for test systems as well. So it depends on how they use the storage. So some organizations may not spend their cost on storing the archive log files. So obviously archive log files need a separate FRA space, which is fast recovery area. So this is the space where we store the backup files, all the recovery files. So when we take backup, we store the backup files, backup pieces, archive log files, then flashback files. All these files will be stored in FRA space. And we store all the data files under Ora data. Ora data is the most common directory. So when we create the directories for storing the files, most of the organizations may be having the common directory as Ora data. So while we install the Oracle database itself, we specify this directory. So we specify the Oracle base and also Oracle data file directory. And it is not mandatory that we store all these data files under Ora data. We can also specify some other directory structure. That depends. If we want some other customized names also we can give. And for FRA, there is no specific naming convention, so we should be specifying a separate mount point for storing all the files. There should be separate directory structure. So whenever any SQL is executed, so in database only SQLs are executed. Apart from that, nothing else will be running. Once the SQL is executed, this is the client side. Client means the user who is executing the SQL. Anyone, application team, or even DBA. If someone is connected remotely, anyone who is connected to the database and executing the queries and performing the task, he is a client. And when the client connects to the database using the TNS names file, and so he will be having the TNS entries. So he has to specify all those entries in his client machine in the connection string. So it will be like this. Most of the clients, there will be a developer or application team. They will be connecting to the database using SQL Developer. They will not be having access to SQL Plus. Only DBA, since he has access to the database directly, he can connect to the server and access the machine using SQL Plus. Also, if someone who has to connect through command prompt and someone who has access to the command prompt, they can also log in. Here we have the properties. So if I am an application team, then my screen will be looking like this, and I specify the connection entries, the TNS entries. So whatever I specify, the host name, port number, service name, username, everything will be validated by the listener, and it will scan the TNS-names.ora file. So it will just validate if these details are correct or not. So listener is kind of a security. So how a security validate and authenticate the people who are not part of an apartment or a house, and he get the entry and validate the IDs, and he bring the outsiders in, whether he is a genuine person or not. Likewise, listener will check and authenticate all these details, and it will it will fork the user process and the server process. So once the listener authenticates, server process also will be spawned in the server. Forking means what listener does is, listener will just connect user process and server process, and that is the job of the listener. That's it. After that, it will not do anything. A listener's job is only to fork the connections, validate the details, and fork the connections. After the connection is completed, if the listener is down, then there will not be any problem for the existing users, but whoever is connecting as a fresh user, if the listener is not running, they will get error, TNS no listener error. And LREG is one of the background process which is used for registering the service. So when the listener validate and authenticate the details of the user, obviously there will be some service for the database. So I already shown you the service details yesterday. Show parameter service name. So there is a parameter called service name. We can check the service name using that command. Every database will be having unique service, that service name needs to be registered with the listener. Then only listener will be able to authenticate the details of the user. So if the user provides the service name, this is the service name. If this service name is not registered with the listener, then also we'll be having issues. So what we do is, if sometimes we get issues related to service name, we just register it. So simply we just execute this command alter system register from the database. This will register the service name with the existing listener. So currently my listener is not up and running, so let me start my listener. If it is not registered, then listener will show listener supports no services. If the service name is registered, then we will get the service name details here in this after this description we'll get it. So that I will the listener details I will take in a separate class. So once the LREG register the service, then user process once the server process the user process validated, server process will enter the PGA, and inside PGA it contains all the information related to the SQL that is executed, like the cursor information and all this information, and the cursor will be initiated. It is kind of a pointer. So how so we have a pen, so that pen is writing on the notebook, so that pen is having some pointer, so that pointer is connecting the user or the person who is writing and the notebook. So similarly, this cursor is the one which is acting like the pointer, and it collects all the details of the SQL. And obviously every application users who are connecting to the database, if they are using some PL SQL codes and all, they should be initiating some cursor. So that cursor will be kind of a real-time we can say it executes the SQLs in a real-time manner. So it stores all the values of the SQL. So the once the server process enters the shared global area, all the shared information related to the SQL will be stored in the shared pool. So inside shared pool, first that SQL statement enters library cache. So library cache contains the information related to the syntax, and there will be 3 checks: syntax check, semantic check, and shared pool check. So data dictionary cache contains the permissions of the user, whether the user is having permissions to access the semantics of the user. So all these details will be validated, and it also contains the statistics information of all the objects on the database. And result cache is optional, so even we can also disable result cache. By default it will be disabled. If you want, we can enable it. So everything is a parameter. Whatever we want to control has a parameter. So with the help of these parameters only, we'll be able to enable or disable it. So currently result cache mode is manual. So if we want, we can also disable this. It is not mandatory. And result cache is specifically used to store the subqueries, which is query within a query. So if I write a query like this, something like this, select star from, and another query, select star from table, something like this, where row num. So we have a bracket here. So this is an outer query and this is an inner query. So this is called subqueries. So in a real-time real-world systems, definitely we will not be seeing a query without subqueries. Most of the queries will be having subqueries if there are complex logic. So if the database is read intensive, so already mentioned that there are two types of systems, OLTP and OLAP. OLTP is transaction processing and OLAP is analytical processing. Most of the analytical processing would be requiring result cache, so that we need to remember. Why? Because analytical processing reads the data very often. So result cache is mostly beneficial only for the read intensive databases. Even for sometimes OLTP systems also may be sometimes read intensive, so we need to validate the benefits. So if there is some benefit in enabling the result cache, then we can enable it, but there is some additional processing will be involved, and also additional shared pool space will be involved, so that also we need to consider. So if we are not reading often, then there is no point of enabling and causing some overhead. So if almost 90% of the databases read select queries, in that case enabling result cache will be beneficial. So once the shared pool, the semantic check and parsing, so that is called as parsing. So we have these three phases: syntax, semantic and shared pool. This is called as parsing. So once the parsing is completed, then the server process will, once the parsing of the SQL is completed, then optimizer generates the execution plan for the query. So every SQL that is entering the database, there will be a hash value. We should also note this point, remember this point. There will be an unique hash value that will be generated for every SQL statements. Why? Because Oracle need to make sure that the SQL is not recursive or repeated. There are two SQL statements, A and B. A is executed and B is a new statement. So in this case, Oracle will generate a different hash value for A and a different hash value for B. So both are select queries. So just imagine. In this case, I am executing the A SQL statement for the second time. If I am executing the same SQL for the second time, hash value will be same. This hash value will be stored in the shared pool. Then Oracle don't need to again generate a new hash value. Oracle can reuse the same hash value. So I already explained about soft parsing and hard parsing. Every SQL statement which is executed for the first time on the database will go through hard parsing. Why? Because Oracle has to do everything from the scratch. But for soft parsing, Oracle can reuse the generated code. Even if the same SQL statement execute for the 100th time, the same hash value will be there, and this hash value will be used to generate the SQL ID. SQL ID is also an unique alphanumeric 10 digit or 10 digit code, and it is 10 or 13. We need to check that. So this SQL ID is the one we use to identify the SQL. Every SQL has a unique ID, and we need to this SQL ID will be generated based on the SQL text. Oracle automatically has some internal algorithms to calculate this. So these two are important. These two are generated during the shared pool check, and once the hash value and SQL ID are generated, then at the same time optimizer also will generate the execution plan. Optimizer will evaluate which path is correct. The optimizer will check if it can enter the data is there in the buffer cache or the data is there on the data file. So based on the existing statistics in the data dictionary, so without the statistics, optimizer will not be able to estimate the good plan. Why? Because if statistics are old, then optimizer will generate the execution plan for that old statistics. It will not be able to understand the new statistics. So consider that I'm just inserting some records. Optimizer, data dictionary has the statistics of this red box. Say for example, this is the data dictionary assumes that this is the latest statistics. Now I inserted some data. One block got newly inserted, and checkpoint happened. DBWR flushed this block to the disk. So at this point, the particular table is having some new set of rows, but the statistics collected is only for this block. This block statistics is not updated for this block, newly inserted blocks. So in this case, optimizer also will go and check the statistics when it generates the execution plan. It will the statistics will be shown as this until this particular block. So optimizer will think what is the efficient way to access the data when I request the data. So optimizer will generate the fastest possible way, whether it can go and check the buffer cache and go and check the data file, something like that. Just imagine. But in reality, it is a more complex way of generating. But yeah, in a high level, it happens like this. The only thing is it will check whether so in between there will also be index. We need to consider that as well. So optimizer will check whether it can use the index or whether it can directly scan the whole table, something like that. So in this case, optimizer will not know. It uses the old statistics, so that it will generate the execution plan to access this particular to access in a faster way for this particular block. But actually we have another block as well, so optimizer has to update its execution plan. So once the statistics is updated, then only optimizer will know that there is a new block in the here. So we need to the execution plan should be something different. So I have two different set of data, so I need to make sure that I need to generate a good execution plan to cover these two blocks instead of only this one block. So that's how the statistics come into picture. So we need to calculate we need to gather the statistics often if they are bad. So we have LRU algorithm in database buffer cache. Based on the LRU algorithm, all the least recently used. So this is a common data structure used in all the database systems in the cache layer. If you see on every database like SQL Server, MySQL, most of the databases, they will be using the same LRU structure. So what it does is all the blocks will be checked. So what are all the frequently accessed blocks? Say for example, this block is accessed 10 times, this block is accessed 9 times, this block is accessed 8 times, something like this. And LRU will check which is the block which is frequently accessed. So it will pin all these blocks, whatever blocks which is accessed most frequent times. And this block is accessed one time. So what it will do, this block is the candidature for the flush, which means since there is no point in storing a block which is not even accessed, but there are a lot of other complex processing that happen, but at a high level it do like this. This one block will be the candidature, one of the candidature for the flush. So this block will be marked as dirty buffer. Dirty buffer means those blocks are the candidature to be flushed to the disk, which means saving it will be saved to the disk. Why? Because the buffer cache is a limited space, it cannot store unlimited data, so it stores the data in a wise manner. So whatever data which is frequently used, there is a purpose. So if I store only the frequently used blocks, that will be beneficial both in performance. Instead of storing the frequently accessed blocks, if I store this infrequently accessed blocks, then every time I need to scan the disk. Obviously scanning the disk is expensive compared to scanning the memory. So every disk scans will seek an IO. So IO means input output, which is there will be a communication between the memory layer and the disk layer. So obviously we need to avoid unnecessary disk IOs. For that reason, this LRU algorithm will wipe out all the infrequently used blocks, and it will save the data using DBWR. So DBWR, it periodically writes in a lazy manner. So lazy manner means it will not frequently flush the blocks compared to log writer. But what log writer does is it writes the blocks from the log buffer to redo log file every 3 seconds. There are 3 points. Second point is every 1/3 of the log buffer full, and also for every commits. These are the 3 criteria for log writer, and these are the 3 basic criteria. There are also other internal internal processing which may happen, and even for DBWR as well. So DBWR not only write the dirty buffers or the dirty blocks when a checkpoint happen. So as I already explained yesterday, that whenever a log switch happen, so consider there is a switch between this log file and this log file. So log writer need to write from this particular log file to another log file. So when log switch happen, there will be a sequence number. So say 1, 2, 3. So this is how Oracle tracks all the switches. So this 1, 2, 3 is a log switch. So again there is another log file, means again it will go to another log file. So that will be 1, 2, 4. So this log sequence number will be used for tracking the switches. So for this 1, 2, 3 log switch, there will be it will signal, log writer will signal saying that there is a log switch happening. It will signal the checkpoint process to make sure that all the data is saved. Why? Because if one log gets full, all the data needs to be saved to the data file. So since read log file cannot be added, only 3 read log files will be there. So we can also add other multiple read log files, but automatically these files will not be extended. So if we add only 3 read log files, only 3 read log files will be used. So since it is switching between each other, all the data needs to be saved. So if one read log gets full, again that read log will be overwritten after some time. So when the same read log is overwritten, obviously we lose the existing data for recovery. Since the log writer is writing data frequently for the recovery purpose, since all these changes are recorded, DBWR will not frequently write the data to the disk. So that's the reason log writer will write the data in a faster manner, so for recovery purpose in case of crash failure. So for that reason it will signal the checkpoint. So once the checkpoint happen, checkpoint will again signal the DBWR. So DBWR, then it will write all the dirty buffers. What are all the blocks which are marked by the LRU algorithm as infrequently used blocks, they will be marked as dirty buffers. And again there are other concepts as well that I will explain in advanced topics. We have different states or different states of the blocks in the buffer cache. So we have pinned buffer, we have dirty buffers, we have free buffers. So that I will explain later. And yeah, so once the DBWR flush the data to the disk, then until the checkpoint is completed, this switch will not happen. So as I already explained, if there are 3 read log files like this, so one switch will happen, second switch will happen, but during the third switch, the first log is already having some data. In that case, it need to overwrite this first log file. So for that reason, the checkpoint, for every checkpoint, DBWR need to write the data, but DBWR is not, since DBWR should save all the data in a parallel manner, so it will not write in a single process. It will be having multiple parallel threads which will write all the data to the disk. So since multiple parallel process needs to coordinate, so it will take some time to write all the dirty buffers. Why? Because buffer cache contains some huge amount of data sometimes. So that also depends on the settings. So again, that is some complex processing. So in this case, redo log will switch very frequently. Why? Because redo log is having some limited size, so but data files are big. So we can add up to 30 GB of, if we add one data file, we can add 30 GB. So, but for log files, we cannot simply add huge log files. Why? Because there are a lot of compromises between the size of the read log files. So if we add a big read log file, then we compromise recovery. If we add small log files, then we compromise performance. So there is a two end compromise or trade-offs. Big log file. Yeah. So yeah, quickly it will write all the changes. So again, there is also other advanced concept that I will explain later. So for every undo also redo will be generated. So that I will explain. But as of now, I will just explain the high level. So yeah, performance also will be impacted if the redo log size is small. So we need to calculate the correct size of the redo log file. So that's the reason we cannot add redo log file similar to a data file. So data file is just storing the data, that's it. But read log file is storing the most critical recovery changes which is needed for recovery. So anytime if crash happens, this read log file only will be checked. So data file is just an independent file which just stores the user data, that's it. But data file is also critical because it is the one which contains the user data. Data file is critical for the business, and read log file is critical for the recovery. In this case, obviously, even though we size the read log correctly, still the switch happen in a split second. So if we are in a banking system, obviously there will be a lot of intensive DML statements. So if intensive insert update delete happens, switch happens in seconds, 1 second manner. So just for example, in this case, every 1 second for every switch, so for one switch, second switch, third switch, every switch, checkpoint will be signaled. So just imagine how it need to coordinate. But checkpoint does not have the overhead here. Why? Because checkpoint is just signaling DBWR. So it will pressure the DBWR to write all the dirty buffers. So the main work is done by the DBWR, not the checkpoint. Checkpoint is like a manager, that's it, who is just assigning the work. But DBWR is the worker who need to do all the work. So in this case, if checkpoint is signaling DBWR for every 1 second, just imagine DBWR cannot cope up with the checkpoint. So that's where we have some performance connections between each and everything. So that I will explain in case you are going for a performance tuning course. I will explain all these. So yeah, we already seen other pools as well: large pool, Java pool, streams pool, which are optional pools. So large pool is used specifically for Arman, and also it contains the IO channels. Java pool is used for Java applications like JVMs, and streams pool is used for replications. We have legacy streams, Golden Gate, Data Pump. So for all these, Oracle use a concept called advanced queuing. So it will just queue all the replicated data. So it is a message queue. So all the data will be stored in the form of message queues, and the data will be sent. And flashback buffer. So flashback buffer stores all the flashback logs. So if we enable flashback for recovery, all the logs will be stored in the buffer. And we have RVWR process, which will write all the flashback log files to the flashback buffer data to the flashback log files. So coming to the background process, so we have SMON, PMON, checkpoint, DBWR, log writer. So I already explained checkpoint, DBWR, log writer. So SMON is system monitor. So I already explained the part of SMON. So SMON is a maintenance process. So what it does is, the primary responsibility of SMON is to perform the recovery and other maintenance tasks, cleaning up the temporary segments and all these stuffs. So whenever there is a failure, crash failure, so if the database suddenly crash, then what happens is SMON will suddenly check the redo log file, and it will make sure that all the crashed data are consistent. So I'm just aborting my database now. So once I abort the database, if you see, here let me monitor the log file. So once I start the database, crash recovery will be happening. So since I aborted the database abruptly, so in real-time systems we don't manually abrupt it, but there may be some disasters. So in case of any earthquakes or any data center issues, any physical server hardware issue, something like that, there are a lot of reasons for a database crash, right? So downtime of database is expected. So during a database crash, after we start the database, Oracle has to do the crash recovery. So if you see in alert log, we have a message beginning crash recovery of 1 threads. The recovery start at checkpoint. So completed redo scan. So it does some recovery. So as I already mentioned, that redo log file is critical for the recovery. So this is automatically done. So when there is a crash and when we start the database, we don't need to do anything. Oracle automatically do the crash recovery. So you need to remember this as well. This is called as crash recovery. Obviously, crash recovery will be used most of the time whenever there is a crash, and in future we perform media recovery as well. So that is part of taking the backup and doing the recovery manually. So that is something different. So for that reason I am explaining this. So if you see recovery of online redo log, there is a message. It has recovered almost 0.01 MB of data. So SMON is the process which does all these check. So it just checks the redo log file and makes sure that whatever data which is not so in this case what happens is all the committed transactions will be roll forwarded and all the non-committed transactions will be rolled back, which means during the crash, so at the point of crash, if I commit some data, then all those data should be saved to the data file. So that is how the ACID rule is mentioned, right? So C stands for consistency. So if Oracle does not Oracle is not complying to this ACID policy, then it fails. It is not following the RDBMS rules. So for that reason, every database software will be having some mechanism to make sure that all the data are consistent. So I cannot simply say that even after the application user commit the transaction or save the transaction, if there is a crash failure, I cannot say that since there was a crash, your data is lost. But application team will say, tell that I already committed and your database is ACID compliant. Then how you can say that data is not there? So obviously there will be some legal issues saying for the Oracle, right? So they will just open a legal case saying that if customer is very critical, he is very you can say if he is very cautious about the data, that not even one point of data should be lost. So at that point of time, obviously customer will thrive for the data. So in that case, even though if they commit the transaction and if the data is somewhat inconsistent, then yeah, so for that reason all the committed transactions should be saved, which means that is the technical term that we use for roll forward. Roll forward means SMON will scan the read log file and it apply or save the data to the data file during the crash recovery. And all the uncommitted transactions. So uncommitted means I'm executing an insert statement, but I have not executed the commit. So at that point, obviously they are uncommitted. So those transactions will be discarded from the database. And PMON is the process monitor. So it is kind of a we can say monitor process. It will monitor all the processes. So it is the father of all the process, or we can say parent, and it will keep on pinging and checking the other process whether they are healthy or not, and if there are any unhealthy process, then pmon will clean up all those process. That is the main goal of pmon. And there are also other tasks which will be done by pmon. So also for smon, it also cleans up the temporary segments. So obviously every database will be having some temporary area, so sorting, hashing and all. So for performing these temporary calculations, Oracle use some temporary segments. So all those temporary segments will be stored in the database in the files. So we have temp files in the database. So for all those temporary calculations, data will be stored in the temporary segments. So once the calculation is completed, there should be some process which should clean up all those segments, right? Why? Because these calculations are temporary. I'm just doing those calculations in the spot, and I don't bother whether I need that data or not. So internally all those sortings and hashings will be done. So once the calculations are completed, smon will go and clean up all those temporary segments to reuse the temporary segments. So temporary segments will not store the data permanently. It will temporarily store it for these calculations, and then it will again reuse the space for other calculations. So temporary operations like sorting, hashing will not only happen in temporary segments, it will also happen on PGA. So that's where we have other main tasks performed by PGA. It is not only for storing the private information of the SQL. PGA also will store these temporary calculations as well, so in the memory. So if PGA is not sufficient to store all the sorting and hashing information, then what it will do is it will pour all the data to the temporary file. So temporary file, we can add multiple temporary files. We can also add 100 temporary files on the disk, but memory is limited, so we cannot add 1 TB of memory or 2 TB of memory. So it costs more compared to the disks. So that for that reason, when the PGA gets full, all the data will be poured to the temporary files. So these are the main use of PGA and also the temporary area. So yeah, what is sorting and hashing? So sometimes we use group by classes, aggregate functions in the SQL. Select star from table, or select column name, count of star from table, group by column name, something like that. Or we use order by class, select star from table, order by column name, descending or ascending. So for these purpose we use the PGA. So yeah, other processes are not mandatory. So some of the processes are part of distributed systems. So most of the databases will not be distributed as part of Oracle. Since Oracle uses a single architecture, so this pman and all, they are not, you will not be seeing, so they are not that mandatory. And archiver process we already know. So what it does is it will just scan the read log and archive the file in separate files. So archive log files can be unlimited. So as per the storage, we can store archive log files, and also flashback log files can also be stored unlimited. But yeah, see, we have limited storage. So as per the limited storage, we need to either copy these files to a different disk, which is inexpensive, or we can copy it to tape or something like that. And archive log files also can be copied to tape. And password file. So yeah, let me complete the background process. So the other background processes are mmon, mmnl, reco. So reco also you can ignore. Why? Because reco also is part of distributed systems. So we will see mmon and mmnl. So M1 process, what it does is it will collect the snapshots, and you can consider this M1 as a performance collection. So what this M1 does is it will just, so how we are using the camera to take pictures, videos and all, likewise M1 will just capture every events on the database, not the application related events but the system related events. System related event means, so for every operations or tasks which are happening on the database has some metrics or statistics, right? So that's how we measure the performance. So I have a Windows machine, so I have memory disk, I store all the files, I do everything, but there should be some metrics, right? So how we measure the performance with the help of CPU, memory usage, disk usage, network, we categorize these things. Power usage, if you see the performance, we have a metric called CPU utilization. So CPU utilization itself is a metric. Memory usage, this is another metric. Disk active time, this is another metric. So likewise there are certain metrics which are used to measure the performance. So based on that, you see disk usage is almost 100%, so per 60 seconds. So something like that we measure based on the capacity and the usage and the page file and all these stuffs. So these metrics needs to be collected. So this is the M1 process is the one which will collect all these metrics, like the CPU usage, the wait events, the memory usage, network bandwidth, latency, lot of things are categorized. So it is not only limited, but M1 calculates like thousands of metrics. So all these metrics needs to be stored in a snapshot. Snapshot means, so it's kind of taking a picture. So say for example, so you are going for some vacation or somewhere, some unique place. So you are going to scenery, some hill station. So in that hill station you need to record all those things, whatever you are doing. So every 1 hour you are just recording whatever you do. So if you are going to a beautiful place, or if you are having food on that place, and if you are enjoying with your friends, so every time you are taking a picture from your camera. Just imagine you are taking picture for every 1 hour, so that later you if you want to check whatever you did, you can go and verify those pictures, so that it will be easy for you to remember, and it will be kind of a memory. So likewise this M1 will capture all the pictures or the that is called as snapshots. It will take a picture of every moment which of the metrics which are collected in the database, and it will store in the form of snapshots. So it may be 1 hour, it may be 30 minutes, so that we depends on the configuration and the settings. So if we can configure 30 minutes, it will capture for 30 minutes. If it is 1 hour, it will, that depends on the interval. So every 1 hour, this M1 is the process which will be the primary responsibility process to calculate to collect the snapshots. And also there are other tasks for M1, but the main or the 90% of the M1's task is to collect the snapshots. So MMNL is also similar to M1. So what MMNL does is it will just sample all the data. That's it. M1 collects the snapshot, MMNL collects the samples. So sample in the sense it will collect the metric samples. So there will be a metric called CPU usage. So this M1 will collect the whole snapshot of 1 hour. say for example, of the CPU usage. But what MMNL does is it will just collect individual samples per minute. So this is also depending on the settings that we configure in the system. So if we enable snapshots, the samples to be collected for every 1 minute, it will collect for every 1 minute samples of the matrix. So the main goal of these two processes is to collect these, and why it need to collect, that is also another thing. So the use cases, we generate performance reports. So there are different performance reports like AWR report, ASH report. So these reports can be generated for whenever there is a performance slowness, we generate these reports and diagnose. For that reason, these data are collected. So yeah, these are the background processes. So let us come to the files. So we have password file. So when the server process is initiated and when the user is authenticated via listener, if the user is if it is not only specific to the user, but okay, so in this case application user will not be part of password file, but whenever we whenever any user that is having admin access, so all this admin access, DBA role, whoever is having those access, all those informations will be stored in the password file. So there is a view which is $password. Yeah, $password file info. This is the view. So this view will store all the information related to the password file. So if you see, it contains the location of the password file. So by default, we should remember that the location of password file will be under DBS location $Oracle home DBS followed by the password file. Yeah, so to be simple, password file stores the credential information about the user, and control file. So this is very important file, and it is also crucial for the consistency. So control file generally stores the information about the database. So it is kind of a metadata. It does not store the actual data. It contains the metadata information about the database, like database info, what is the database name, and when the database was created, and it contains the information about the backups and the SCN. So yesterday I already explained about the SCN. So what is SCN? System change number or sequence control number. So the system change number will be generated every second. It keep on changing every second, and so whenever this checkpoint happen, the another important task of checkpoint is to make sure that the headers of control file and data file are in sync or not. Sync in the sense, so we mentioned consistency. So how Oracle checks or measure that the database is consistent or not? So whenever checkpoint tell the DBWR process to write all the dirty buffers to the data file, it also makes sure that, so every file, so before that I will explain that every file in the database have a header which stores the metadata information about that particular file. Here control file itself is a file which stores the metadata of the database, information of the database, but that control file itself will be having a header, like how so you are reading some book, so in that book you have some header and footer, but here we don't have any footer. Here we only have the header. So in the header, what you will do, you will just you'll be having the heading, the topic of the chapter that you are reading and all this stuff. So likewise, every file will be having the header where all the metadata information about that file will be stored. That file, in the sense, here if control file is having a header, it will store all the metadata information about that control file. So likewise, in the control file header, it also stores the SCN information. SCN means the system change number. So as I already mentioned, for every log switch, a sequence will be generated, and for every block changes, SCN will be generated. So if this particular block is changed, this red block is changed, immediately it will be stored in the log buffer with a system change number, and that system change number will be referred during the recovery. For that reason, Oracle generates unique number. So that system change number should be synchronized, which means both the data file header and the control file header should be having the same sequence control number or system change number. So similarly, in data file also there will be one header. So that header will also contain the details about the file, and also it contains the SCN. So if say for example this there is a change for this block 1 2 3, this 1 2 3 will go, this change will go to the log buffer with system change number 1 2 3, and log writer will immediately flush the blocks to the online read log file, and it will store that SCN block to the online read log file. So again, there is a switch. Because this log file is full, it is going to the next log file. There should be a switch. So once the switch happens, checkpoint will be signaled. During the log switch itself, not after the switch, but before the switch itself, there will be a checkpoint. So once checkpoint is signaled, it will immediately signal the DBWR to write this block to the disk. Why? Because that online read log file will be overwritten next time. So for that reason, again it will go to the control file, and it will make sure that once the DBWR write all the SCN information, it also write the SCN on the control file as well, the checkpoint process. So in this case, both the control file and the data file should be having the same SCN number. If control file is not having the recent SCN, if control file is having the old SCN number, then we have inconsistent data. That is how we measure how the database is consistent or not. So this also I will explain later, how we check whether so this is what we called as. So I don't want to go deeper. So there are a lot of technical terms involved. So yeah, to be simple, there should be some consistency. So both the SCN number should be same in the header files. So yeah, this is the main use of control file. So also we use the control file for storing the backup information. So yeah, since it is just a metadata file, we store this. So control file should be multiplexed. So multiplexed means we need to store multiple versions of the same control file for backup reasons in different locations. So if one control file is lost, we can use the other control file for our consistency. And yeah, data file stores all the application user data, and also it stores the dictionary information of the data. So we have different table spaces. So table space I will explain later. And yeah, server process, again, server process is not a background process, but when the user process is connected to the database, as I already mentioned, server process will be initiated. So that server process is the one which will coordinate. So it is also called as foreground process. So as of now, you can remember as server process. You don't need to remember multiple terms. So this server process is the one which will retrieve all the data, right? So if user is executing a SQL query, so here parsing will be completed on the shared port. Once the parsing is completed, the next phase is execution. Okay, so if that depends again. So if we use a select query, then that goes into certain phase. If we execute insert update query, that goes into another phase. So these are all part of performance tuning. So these are quite advanced topics. So we have fetch, execution as well. So once the SQL is parsed, we execute that SQL statement. So execute in the sense, parsing is just the scanning phase. It is just validating the SQL for whether the syntax is correct, whether permissions are correct, all these steps. But that SQL needs to be retrieving the data from the buffer cache and the data file. So if the data is not stored completely in the buffer cache, then again it has to go and check to the disk. So in this case, if disk is not, if a buffer cache is not having the data, all the blocks in the disk needs to be scanned. So which process will scan all these details? Server process is the one which will scan all the details, which means server process will read the blocks either from the buffer cache or the disk. There are no other background process that will do this. Why? Because since user is the one who is requesting the data, the user who connected to the system will be having a server process. That process is responsible for the reading of the blocks when he executes the select query. So these also will be asked in the interview question. So which process is responsible for reading the data blocks from data files and buffer caches? And archive log file I already mentioned. So since archiver process will archive the archive log files, it will write all the files. Then P file. So this is also very important. We have two files, P file and SP file. So P file is a parameter file. So in every database flavors like MS SQL, MySQL, even in Teradata, obviously there will be some configuration file. Without any configuration file, we cannot do any configurations. So in Oracle, we name it as P file, which means parameter file. So this P file stores all the parameters which are mandatory and necessary for starting the database, like database name and what mode it should be. A lot of things are there. So the location of the data files, location of the control files, something like that. So that I will explain in practical sessions. And we also have another file called SP file. SP file is a server process file. It is also a similar version of P file. So P file is just a text kind of file, but SP file is also a text file, but it is generated by Oracle itself. So if we need to manually need control over the parameters, we can use P file. If we need to automatically change the parameters from the database, automatically in the sense, when we use P file, we cannot change any parameters in the database. But when we use SP file, we can change the parameters at the database level. That is the only difference between P file and SP file. But you will understand the purpose of these two files when we do the practical. So P file is just a one-time file. So if we want to configure the database for the first time, so during the installation we need to configure some parameters, initial parameters. At that time we just use the P file to configure all these values, and we start the database with the help of the configurations or parameters used in the P file. So once the database is configured and if it is running, then we no longer use P file. Why? Because using P file, we need to every time specify that P file for starting up, and also we cannot change any parameters when we use the P file when the database is running. So that is the main disadvantage of using P file. So it is kind of a one-time file, that's it. And sorry. Okay. Mm-hmm. Mm-hmm. Yeah. So you use SP file as well? Yeah. So if you just use P file, so currently if you see, I'm using SP file. So if I just say show parameter SP file, I have some location here. So here I can also create P file from SP file. So we have this command, or we can also create SP file from P file, something like this. So P file is just a text file, that's it. So SP file is also kind of a text file, but if you see, SP file will be having some different format, some star and all will be there, and also you have something like this, some clumsy text inside this. So modifying this SP file is not recommended. So why? Because this SP file is completely generated by the database itself. So what we can do is, okay, so again I got the space issue. So if you see, let me just show you a sample file. So this P file, we can edit anything. So if you see, all the minimum parameters that are required will be there. So this is just a sample file. So init.ora, if you go to this directory, Oracle home DBS location, we have this init.ora. This is a sample which can be used, or you can also call as template. So if you want to create an actual P file, always the P file should be having some suffix. So the prefix is init followed by the database name. So what is the database name? This is the database name. So init database name.ora. So we need to create a file like this, and if we want to configure parameters, we can just go and check this file for reference. This file is just a generic file, so it contains some generic information, DB name, memory target. So if you want to increase the memory, we can increase the memory. If you want to increase the process, all these configurations can be done. So once we configure this, we start the database with the configuration. So yeah. Initially, when we install the database, P file will be there. So Oracle uses the P file to start the database. So if there is no P file, we can also create manually. We can create the P file, and like how I said, create create p file from sp file, or if you in your test machine also you can try this command, create sp file from p file. So automatically this sp file will be created. So if sp file is not there, if you just type show parameter sp file, you will not be seeing any values here, any file names here. Once you create the sp file from p file, you will be seeing the values. So automatically I can use any alter commands to change the parameters. So that is the main use of sp file. And also, yeah, this is the password file. Password file always starts with the orapw, that is the prefix, and the database name is the suffix. So this password file we use it just for checking the admin and DBA related roles. Most of the time this password file will be used specifically for data guard configuration purpose. So we don't use it in single instance, so we use it only for data guard. So yeah, that's it. This is the architecture part. So if you have any doubt, you can ask. Okay. So I will also cover the startup modes and shutdown modes tomorrow. Which one? Yeah. Startup no mode is nothing, it's just a simple session. So installation of database I will cover later if it is not needed. Why? Because since you are practicing in your dev machine, so obviously the real-time configuration of servers and these things are completely different. So what we are doing is we are just creating a VM machine, and on top of that virtual machine I'm just installing the server. So obviously in real-time systems we don't configure the servers and all. So I will just if you want, I will just take separately about the installation now, or at last also I will take that. That's fine. Okay. Yeah. Okay, fine. Yeah, we'll if installation is needed, then I will tell how. I mean, I will show you how the installation works. It is just a graphical window where you will just click next. That's it. There is nothing much. So yeah. Mhm. Okay. Nothing. There is no such thing. Nothing different. Only thing is you need to choose the location and all. So there is nothing complex. Tar files. Okay, I just need to see what is exactly what they are doing. I'm not sure. Maybe the process may be different between the organizations. General installation process is same for every organizations. So some in one organization they just take take backup and restore on another system, something like that. Instead of directly installing, they just clone the database, something like that. There are different ways of installing the database. So yeah, I just need to see what they are exactly doing. Okay. Okay, yeah, today's session is over. So if you have any doubts, you can ask. Otherwise, we can wind up for today. Okay. Okay, fine. Yeah, sure. Thank you. I will share you the recording. Yeah. Right.